All right, outro. Welcome back. Here we are today. We are continuing to talk about polynomials. We are going to talk about factoring today, which is essentially pretty much our multiplying polynomials that we did on Monday, Tuesday. We're just going to do it backwards today. That is our idea or our goal today. Just be able to do that stuff backwards. So you have this warm up. We had to fill in the boxes with whatever was needed to be there in order to make sure these equations are true. And we could use numbers, letters, whatever, to fill in these boxes. So some strategy you might have thought was, well, I know I have to, you have to take that first number times the first number, and then times the other, and then, wrong line, and then 3 times this, and then 3 times that. Will give you, added together gives you this full thing. Well, we know, we kind of could skip some of these steps because we know the first two multiplied together, 2x times 5x to something, is going to have to be, that always ends up to be our first term. And our last two multiplied together, that always ends up to be our last term whenever we multiply. So using this, we could kind of get an idea of what we would need to put in here without having to necessarily do all this multiplication, like test a bunch of things. So we just have to think 2x, let me put it in the right color at least. 2x times 5x to what number would give us 10x to the fourth? Well, 2 times 5 is obviously where the 10 comes from. X times x to the what number is going to give me x to the fourth? Well, I know my exponents add, so if this is x to the 1, 1 plus 1 gives me 4, well, it's 1 plus 3. So I know 3 is going to have to be my first box. 3 is going to have to be my first box. We can use that same strategy to help us figure out the last part. We know it's 3 times some numbers, letters, whatever, is going to have to give us 6x squared. Well, 3 is just a coefficient, so we know our coefficients multiply together. So 3 times what other number is going to give me a coefficient of 6? 3 times 2. And then neither of these values have an x squared in them so far, so I know I can just add on an x squared because currently 3 has no x's. So in order to get these x squareds in here, I'm going to have to at least have x squared. So 3 times 2x squared would give me 6x squared. And so I know my first box would have to be 3, my second box would have to be 2x squared, and those would be our 2 boxes. So hopefully you got that in the warm-up. So once again, we're going to continue talking about how we can do this stuff backwards once again. This is kind of a little bit of an idea of what we'll need in order to help us start off with that. So let's start off by talking about factoring to find zeros. So our whole reason that we are factoring, our whole reason that we're doing this, is learning how to do this backwards, is because this can help us solve for the x-intercepts of quadratics. Without having to graph my quadratic at all, I can solve for the quadratic by figuring out what the zeros are, by figuring out where my quadratic equals 0. And I can use that by doing this factoring method. So essentially what we need to do is we need to figure out what are those two factors, what are those two factors, those two pieces that were in parentheses that multiply to equal our quadratic. So x squared plus 10x plus 21. What were those two things? Typically it was like x plus some number and x plus some other number. Those were our two things that typically multiply together. But once again, so we, on Monday, Tuesday, we went from this direction. Now we're going to learn how to do it backwards. So I'm going to teach you a method called the box and diamond method. So if you prefer the box method, the area method on Monday, Tuesday, then this might be a little bit easier for you today. But this is called the box and diamond method. The reason it's called the box and diamond method is because you're going to make a box, as shown on the board, and then this little X. When I was in high school, it was a diamond. You would make a diamond, but an X is fine. So all you have to do is make an X. But I will call it a diamond, and I apologize if you ever get confused. But the X is the diamond. So what we need to do first is in the top part of my X, top part of my diamond, I'm going to take the first value of my quadratic and the last value of my quadratic. I'm going to multiply them together, and I'm going to throw that into the top part. So x squared times 21 is going to be 21x squared. That's always going to be the top part of my x. I'm going to take the middle number of my quadratic, my trinomial, and I'm going to put that as the bottom of my x. So 10x is going to be in the bottom. And this part is where we're going to have to think a little bit. So we're going to have to do a little bit of thinking on this. The left and the right, I need to think of two numbers that multiply, two expressions that multiply together to give me 21x and add together to give me 10x. I need to think of two numbers that multiply together to give me 21x and add together to give me 10x. So we have to think a little bit for this. So whenever it says product means multiplication. So we're thinking of two numbers that multiply to get 21x, two numbers that add or a sum for 10x. Now I know in order to get that x squared, that both my product and my sum are going to have to be x and x. I'm going to have an x for each of these. So x times x gives me x squared, and then x and x will add together to give me my 10x. So really, I just need to think about the 21 and the 10. These are the two important pieces that I need to think of. So what are two numbers that multiply to give me 21, add to give me 10? So you probably already thought of these after I've said it like 17 times. But two numbers that might multiply to give 21 and add to get 10, we could try 3 and 7, I know multiply to give me 21, and 3 and 7 add together to give me 10. So 3x plus 7, or 3x times 7x will give me 21x squared. 3x plus 7x will give me 10x. All right, so that is my diamond portion of this. Next thing, now that I have these two numbers, I can fill out my box. I'm going to start filling out my box. In the top left-hand quadrant, we are always going to put our first value, which is our x squared. In the top, or the bottom right-hand quadrant, we're going to put in our last number, the constant, the 21. So the first x squared is always going to go in the top left-hand. The constant number at the very end of your function is always going to go in the bottom right-hand. Our two other boxes, we're going to fill in with the two boxes or the two pieces of information that we came up right here. It does not matter which one goes which. I'm going to put 3x here and 7x up here. But once again, these can be flip-flopped and that would still be fine. All right, so now we have these two pieces. So now, essentially, when we were doing our box method on Monday and Tuesday, we had numbers on the outside of those boxes, and we were multiplying those numbers together to get the inside of our boxes. So we had like x and some other number down here. We were multiplying together to create this inside box. So we thought like x times this, I don't know, x times 4 created us 4x in the box, and we'd fill it in. Essentially, we're going backwards. We have to think what numbers multiply together to create the inside of my boxes. So what two things multiply together to create x squared? Well, x times x creates x squared. X times what number creates 3x? Well, x times 3 creates 3x. X times what number creates 7x? X times 7 creates 7x. And 3 times 7 creates 21. So we're just doing that box method, the same idea we were doing the other day, but we're doing it backwards. And this here is giving me my two factors. It gives me my factor of x plus 7, and it gives me my factor of x plus 3. So my two factors of my quadratic are x plus 7 and x plus 3. So that would be our factor form of our quadratic. Now, once again, the whole reason we're doing this factor form, the whole reason we're trying to get this factor form is so we can figure out what are those x-intercepts of my quadratic, because the factor form always told us the x-intercept. And what we had noticed before is that the x-intercepts were always the inverse of the numbers that showed up in your the numbers that showed up in your factors. So for example, we would get x equals -7 and x equals -3. It was the inverses of those numbers. Now the reason this works, the reason we're allowed to do this is because if we have the quadratic x plus 7, x minus 3, we are essentially looking, when is this quadratic equal to 0? And if we think about it, these two factors are being multiplied by each other. So when do we ever have two numbers that are being multiplied to each other and we get an answer of 0? The only time we can ever have multiply two numbers together and get an answer of 0 is if one of those numbers is 0. So if my first factor is 0, then I can get 0, or if my second factor is 0, then I'll get an answer of 0. But one of them has to be 0. Well, so now we have to think, when do these two factors equal 0? So when would this first factor equal 0? This first factor would equal 0 when x plus 7 equals 0. Well, it would equal 0 only when x is equal to -7. That would be the first instance when my factor would be equal to 0. Or x minus 3 equals 0 would only be equal to 0 when x equals positive 3. So I know my x-intercepts of my quadratic. I know when my quadratic are going to be equal to 0 will only occur at -7 and positive 3. So this is why we're able to jump and do that little shortcut right here from this step to this step. Is essentially what we're doing in this process is we're setting each of those factors equal to 0. So I'm setting x plus 7 equals 0 in solving for x, setting x minus 3 equal to 0 in solving for x. And once again, we can actually check this using Desmos. So looking at Desmos, we can see our two quadratics are showing up actually the same. We see their graphs are the same. If we look at those x-intercepts, we have -7, 0, and we have -3, 0. -3, 0. Did I mess up something? Oh, because it's positive 7, positive 3. I wrote -3 here. That was my fault. I just wrote that. This should be positive 3, which would make this positive 3, which would make this -3, which would make this -3, which would make this -3. Yeah, it's my fault. I missed that. All right, let's look at another example of this. So we have x squared minus 2x minus 3. We want to factor this equation, factor this quadratic, and then we want to solve for 0, solve for our x-intercept. So once again, we're going to do the boxing diamond. So first thing I'm going to create is I'm going to create my little x, my little diamond here. In the top part, I'm going to put my first and last numbers multiplied together. So that's -3 times x squared. It's going to be -3x squared. And then I put my middle term in the bottom, so -2x. So once again, I need to think of two numbers that's going to go in my left and my right, two numbers that multiply to give me -3x squared and add to give me -2x. So I need to essentially think of two numbers that multiply to equal -3, add to equal -2. Well, -3 is a prime number, so the only numbers that can multiply to equal -3 are going to be -3 and 1. Well, if I add -3, -3 plus 1 is going to give me -2. So this is going to be -3x and 1x should be my two values because -3x times 1x is going to give me -3x squared, and -3x plus 1x is going to give me -2x. So I can fill those in as my two boxes inside. I know in the top left-hand corner, I'm always going to put x squared. The bottom right-hand corner, I'm always going to put my last number, -3. And now I just need to fill in the outside. So I need to think what two numbers multiply to create x squared? Well, x in x create x squared. X times what number creates 1x? Well, x times 1 creates 1x. X times what number creates -3x? X times -3. And now I have the outside of my box. So I have my two factors. I have x plus 1 as one factor, and I have x minus 3 as my other factor. And once again, once we get those factors, we can easily solve for our zeros. All we have to do is write x plus 1 equals 0 and x minus 3 equals 0. I'm taking each of those factors and setting each of those factors equal to 0. Well, when does x plus 1 equal 0? If I subtract 1, it's going to be at x equals -1. When does x minus 3 equal 0? If I add 3, it's going to be at x equals 3. So my two solutions should be x minus 1, or x equals -1, and x equals 3. Once again, we can check this using Desmos to see if we got it right. So I have my original function. I have my factored form. They line right on top of each other, so that's good. If I look at the x-intercept, I have -1 and 3, so I know I did it correctly. So we can easily check ourselves using Desmos. All right. The function f is defined as the polynomial, or defined by a polynomial. Some of the values of x and f of x are shown in the table. Which of the following must be a factor of f of x? So I have this table here that represents my function. I'm trying to figure out which of these factors would be one of my two factors that show up for my quadratic. Which of those would be one of my two factors that shows up for my quadratic? Well, we know our factors occur at our x-intercepts. And the x-intercepts only occur when the y value is 0. So the x-intercepts only occur when the y value is 0. So looking at my table, I have a y value or I have an x-intercept occurring at 4. So I know 4, 0 is one of my x-intercepts. Well, what would this x-intercept be written as a factor? Well, we know it's kind of always the opposite of what our x-intercept is. So x minus 4 would be the factor that worked for our intercept of 4, 0. So I know that x minus 4 would have to be a factor of my quadratic. So C would be my solution. All I had to do was look at the table, see where my x-intercept was. I know how to turn that x-intercept into a factor, and I know I just had to look at my options, which one was the right one. All right, so this one's going to be a little bit harder. If we look at our quadratic, we actually have a value in front of our x squared. And this doesn't seem like it changed the problem too much, but it actually adds just a little bit more level of difficulty. Nothing too hard, nothing we can't work through, nothing you guys will find too difficult, but it does sort of escalate the challenge just a little bit. So let's take a look at this one. So I'm going to start off, I'm going to use the same exact method with my box and diamond. I'm going to take my first number times my last number. So this is where it kind of changes, because typically I was just doing like negative 8x squared, but now I have to think negative 8 times 5x squared. That's going to give me 40x squared, negative 40x squared in the top of my fraction. My bottom is still going to be the same. That's still going to be 6x. So I have to think of two numbers that multiply to get negative 40, add to get 6. Two numbers that multiply to get negative 40, add to get 6. Some numbers that multiply to get negative 40 are like 2 and negative 20. But if I think of 2 and negative 20, those can't combine to give me 6. Another numbers that multiply to get negative 40 are 4 and 10 multiply to get 40. Can I use 4 and 10 somehow to get me 6? Well, if I do positive 10x and negative 4x, those should add together to give me 6x and multiply together to give me negative 4x. So sometimes with these, you have to sort of do a little bit of guessing and checking. You have to think, okay, I know these two numbers multiply to give me my top number, but do they add to give my bottom one? Nope, so I'll have to try something else. So sometimes we have to do a little bit of guess and check work in order to get it to work out. So I know 10x and negative 4x are going to fill in my boxes. And then in my top, I'm going to have my first value of 5x squared and my bottom value of negative 8. So now I need to, once again, fill in the outside. So I know x and x is always going to go with the top part. But the thing is, x times x doesn't create 5x squared. I need a 5 to show up in one of those x's. But which one should have the 5? Does it matter? Yes, it actually kind of does matter a little bit. So if we were to put 5 as this value, if we were to multiply through, 5 doesn't multiply by any number to create negative 4. But 5 does multiply to create 10. So I need to make sure where I'm putting my 5 is I'm putting it in a right location such that my factors are going to end up in the correct spot so that I can continue to work out this box. So I see that 10x, 10, and 5 are both factors of 5. So I know my 5 needs to go in this vertical column in order for it to be a factor of both of them. While negative 4 and 1 don't have a common factor among them, so that means, or negative 4 and 5 don't have a common factor in them, so I'm just going to leave this as just x. Now 5x times what creates 10x? Well, 5x times 2 creates 10x. X times what creates negative 4x? X times negative 4 creates negative 4x. And then negative 4 times 2 should create negative 8. So my two factors for this one are actually 5x minus 4 and x plus 2. Now, once again, when we jump to our solving thing, the reason we like to solve it rather than just going straight to my answer, the reason we need to solve it is because this factor right here isn't going to give me a direct solution like we typically do. Because when I set that factor up equal to 0, I have 5x minus 4 equals 0. Typically, you think, oh, our answer is just going to be positive 4. It's just always the inverse of the number that shows up. But because there's that 5 in there, it's actually going to change my answer a little bit. So I'm going to add 4. And I get 5x equals 4 divided by 5. Divided by 5. And so actually, my solution is going to occur at 4/5. That is where my x-intercept is going to occur. 4/5, or is roughly about 0.8. So actually, at 0.80 is where my first x-intercept is going to be. My second x-intercept, though, is going to be pretty easy to find. It's x plus 2 equals 0. So I just inverse 2, and then we get x equals negative 2. So our two x-intercepts are at negative 2, 0, and 4/5, 0. I'm going to do one last question really quick, and that's where we're going to end it for the day. All right, so we have negative 4x squared plus 19x plus 5. This is going to be our last question we're going to do, and then we'll call it. All right, so I know in the top part of my diamond, I have to put my two first and last numbers multiplied together. So negative 4x times 5 is going to be negative 20x squared. I know 19 needs to go in the bottom number, and so I need to think, What two numbers multiply to give me 19, what two numbers multiply to give me negative 20, add to give me 19? Well, the numbers that multiply to give me negative 20 are 2 and 10, 4 and 5. Do any of those combine to give me 19 though? Unfortunately not. But we can try, we can do 1 and 20 multiply to give me negative 20 if my 1 is negative. And then if I add these two together, I can get 19. So we can always try 1 and a number is always another thing. Typically, students tend to forget that option as one of them. 1 times whatever your number is. So 1 times negative 20, or negative 1 times 20 gives me negative 20x squared, and then negative 1 plus 20 gives me 19. So I can then fill in those two values. So let's put this as negative 1x, this as 20x, and then my other numbers can go negative 4x squared and 5. And now I can fill in the outside. So I know I'm going to have x and x, but which of these is negative 4 going to be a factor of? Well, negative 4 can be a factor of 20, so I'm going to put my 4 out here. I also see that I have negatives going up and down this one, so I can assume that negative 1 is going to be a factor. So negative 1 times x squared, or negative 1 times 4x should give me negative 4x squared. Negative 1 times what gives me negative 1x? Well, negative 1 times 1. 4 times what gives me 20x? 4 times 5. And then 1 times 5 gives me 1. So my two factors are 4x plus 1, and my other factor is negative 1x plus 5. So last thing we need to do is we just need to solve. So we have 4x plus 1 equals 0. If I inverse my 1, I get 4x equals negative 1 and divide by 4. I'm going to get negative 1/4 as my solution, or negative 1.25 if I were to check it using Desmos. And then if I do my other one, I have negative 1x plus 5 equals 0. Inverse my 5, I get negative 1x equals negative 5. And then divide by negative 1 to get x equals 5 as my last x intercept. Once again, if you ever want to check these, we can always check them using Desmos. Pull up Desmos. Looks like I didn't link this. And we would be able to check that we would have negative 2.5 as one solution, or negative 0.25 as one solution, and positive 5 as my other x-intercept. That's where we're going to end it for today. Hopefully you pick this up not too hard. You're going to have some practice in a card for after this, and then if you have extra time, or a Desmos, or sorry, in a spiraling practice before your exit slip. Let me know if you have any questions. I hope you have a great rest of your day.